I guess we're good to go. So yeah, here I am, and it's about time. And welcome everybody. Good morning, good afternoon, good evening, whichever part of the world you are in right now. Welcome to the series of webinars we're going to do, and I hope you all are doing safe and solid. So people would continue to come in, and we'll just start right away. And this topic, this topic has been the nerve of the whole enterprise ecosystem. It is not talked about much out there, but I think we believe that this is one of the most important ones. Before you talk about use cases, before you talk about complications of technology, architectures, modules, flexibility, scalability, I think as a sum of whole, to prepare yourself, you must focus upon what it would take in terms of the ownership of the solution, the whole construct of it. So we'll not be doing very detailed mathematics today, but yeah, of course, a high level maths. I'll of course talk about what those topics would be, and then we'll slowly gradually move through each of these topics one by one. I'll for now shut down my video so that we can focus on the slides, and we'll not have bandwidth issues, no lags, no delays. So I think let's start right away. And thank you again for joining in. So what we would be covering today is about the high level construct. How do you perceive an enterprise blockchain solution? We most of us would already know about it, but we'll simply touch upon it, and of course on this slide itself. And then all sort of relevant factors, including the enterprise grade quality, the security aspects, and the performance oriented implementation of a use. No, I would not say use case. I would say protocol first, and then we would talk about use cases. Leaning on the protocol itself. And then, we would talk about the, some of the important determinants, including transaction size and volume being the most important ones. But then, but then we'll continue to talk about the objectives, the organization would require, specifically when, they'll have to focus upon the cost aspect. So how do you, reorient everything, re-architect everything in terms of, the thought process, and focus back upon, the cost aspects within your use case, life cycle. And then we would talk about one of the most important ones, the node management piece, and how it impacts the cost and the surroundings of it, and how you can actually maneuver your way out of it, and become a masterclass in terms of managing your ownership cost. And then in the end, you would definitely talk about the critical aspects in terms of arranging the whole cost of one enterprise blockchain implementation. So like I said, we'll not be diving very deep, because this can go from Mars to moon and then back again. This is such a vast topic, and that's why it's not just one session we're having today. It's going to be a series of it, and we'll be talking about these topics consistently, following each other, backing each other in a manner that you can join all the dots when the session or the series is over. So let's hit the gear already, and let's get going. And so first thing is about discussing what are the possible scenarios, because without drawing the construct. So this is about the construct of a solution. When we attempt a blockchain solution, we have certain things which we need to consider, and based upon those points or factors, we have drawn several scenarios which we'll be discussing today. It won't be very accurate, it won't be very practical. We'll talk about that why as well, but this would be indicative enough that we'll continue through our discussion, and we'll know in the end that how to prepare your mind to approach this, execute this, and maybe master this in the end. So some of the scenarios which you are taking today, there are 4 scenarios. It's clearly there on the screen. So in scenario 1, our focus is enterprise blockchain, but we're not leaving proof of work apart. It's been the legacy of the blockchain environments. It would give us a right comparison. So we're not focusing on public blockchains, but yes, we're drawing the right comparison so we'll understand the construct. So in scenario one, we're talking about, a daily transaction volume of about 250,000. And each transaction reaching up to 500 bytes, which is considerably large. And the hosting environment we are taking in this scenario is cloud-based. We'll talk about different scenarios when we'll reach the node management piece, but this is to create the scenario in your head so that we'll connect well when we'll move through the slides. You can, of course, pop in your questions in the Q&A, and I think Paras is here. He'll help me out with the best of capabilities he's got to answer your questions, or we'll have a good slot in the end for all the Q&As. Second scenario is about a lower transaction volume a day, 50,000 only, not 250,000, something like that. But then the size of the transaction is also medium category, 250 byte. And in this case, we are talking about on-premise setup. So on-premise means, we are preparing it all in our own, infrastructure elements. Now, there could be two different types of, on-premise installations. And that's why we're having a scenario three as well, where, we're talking about 500,000, transactions a day. And then the size would be very, very small. So these could be, you can say, in size microtransactions. And then on-premise again, but here we're talking about new system or implementations, not the existing framework you have on-premise. And then the last scenario, the scenario 4, is very similar, exactly similar to scenario 3 in terms of transaction volume, but the size is slightly higher. So we're considering medium transaction size to 50 bytes each, and then hosting on cloud. And if you see the bottom line of this scenario table, it's about the consensus protocol. It has a meaning to it why we're keeping it different in all different scenarios. And like I said, we're keeping proof of work, proof of authority, proof of stake, and even the Byzantine BFT, because we want to draw a right comparison between the public blockchains and the enterprise blockchain and how the cost differences are, but we'll not primarily focus on public blockchains. So these are the scenarios we'll be going about. And we'll be going about in conjunction to what kind of impacts they're having against each other against some parameters which we have listed earlier. So let's move forward and see. So this is a simulated and some of the experiences we have had with our customers. We kind of collated this data. And again, like I mentioned earlier, this may not be very accurate. This may not be what you are eyeing for one of the use cases you are preparing for. This may not be, the exact number you should plan your budgets upon, but this is indicated enough that, you can actually start thinking and taking the approach. So in scenario 1, the cost is then divided into 4 segments: the onboarding cost, the cloud or the infra cost, and then the ongoing maintenance cost, and then the monitoring cost. Now, these are different factors which we should consider. So onboarding cost is about, going to the market and then letting your, stakeholders onboard the solution. Now, it can be a supply chain solution where, you are the manufacturer, you're onboarding your suppliers, you're onboarding your vendors, distributors, or maybe, other stakeholders, either, upstream or downstream. It has a cost because this is the launch of the solution you're doing. Then there are cloud costs. So in scenario 1, we of course considered that our hosting would be on cloud. It won't be done on on-premise. Cloud can be of 2 different scenarios. We'll talk about them later. But yes, we'll consider cloud cost, where the machines and nodes were running, and then the scaling of the network happens on the cloud itself. And the third aspect is the ongoing maintenance cost. So this is about when the network is live, it's doing pretty fine, but it has a certain maintenance which needs to be done regularly on top of it. And I talked about maintenance first, but maintenance only happens as an outcome or manifestation of monitoring. So it's know and act kind of a scenario. So monitoring your network means you're keeping an eye on everything which happens either on your machines, on your node parameters, on your transaction status, on your block status, on your consensus level things. And then based upon that, you start maintaining the network. So both the costs kind of are relevant to each other, but they have different purpose and they are the trigger. So monitoring triggers maintenance. This is what at a high level you can say. So we tried, extrapolating a 5-year cost. We haven't been running any customer for 5 years, so I'm honestly accepting it. But yes, you can say that this is the extrapolation of what we've seen in last 1 or 2 years with our customers. So in year one, if you see the cost of ongoing maintenance is pretty low. Monitoring, of course, is low as well. The infrastructure cost and onboarding cost is the highest. So monitoring is the lowest because this is the time when you're launching the network. You're not expecting higher transaction volumes. You're not expecting a lot of implementations or maybe executions happening on the network. But yes, you'll have to run the machines. That's where or run the limited number of initial nodes. For example, if it's a Hyperledger Fabric network running a supply chain track and trace use case, then it means that you're running at least one organization, multiple peers, minimum 5 order nodes with Raft running it as a consensus. So you would require a certain number of nodes with certain number of configurations to run this use case. So this is why cloud costs are there since the beginning, and they're consistent and usually high in the beginning because you're not running things on top of it. Then onboarding is the max because this is where you launch it. So most cost which is to be spent in the year one is the onboarding cost, and then maintenance, of course, because this is the year when you'll face most of the challenges, downtimes, bugs, issues, and all, and network related stuff, machine related stuff, scaling related stuff. So this is where you would focus mostly on maintenance cost and onboarding cost. Then in year two, your cloud cost might reduce because you would know how to optimize your transactions. It may take another year. We just assumed it, but we'll talk about it, how it happened, how the optimization happens. I'm considering that in year one itself you have scaled it to the number of organizations or nodes or peers you would require. So in year two, you're primarily focusing on optimizing your cost in terms of the infrastructure. We'll talk about how later. And then the monitoring cost, it would reduce slowly because like we said, we focused a lot upon maintaining the network and fixing everything, sorting out everything to stabilize it properly and know that what benchmarks could be achieved with what sort of application or implementations or monitorings and executions or transaction volumes. So the next year you would slightly improve upon monitoring costs as well. And there is another reason to it. And that reason is something which we'll cover up in the later slides. And that reason would impact your cost model a lot, by big time. And onboarding costs would reduce, I think, exponentially. Reason being, running a solution for a complete year means that you have a whole life cycle implemented already. You have all sort of stakeholders onboarded already. So onboarding may take most of the cost because you'll have to do a lot of DevOps exercises. Bringing in 5 different companies onto one solution takes a lot while you're initializing it. But the next year would be like hunky-dory. You won't worry much, considering everybody's on board, they're running it fine, but you still may have to do certain upgrades, this and that and all. That's why onboarding cost is less, but maintenance continues pretty much the same. Reason being, again, like I said, keeping an eye is the key to have a very fantastic uptime, which is one of the must-haves in enterprise ecosystems. This is why you won't see major differences in the cost on these 2 points: onboarding, maintenance cost, and monitoring cost. You would be optimizing cloud slowly, of course. You would be optimizing your monitoring slightly. Maintenance would be barely the same for all the years. But yes, overall, this is a huge cost. I think that's where I'll stop and we'll move to another scenario because this is a topic we'll cover up in later slides. Now let's look at scenario 2, 3, and 4 at the same. Just look at them all together, because now we are comfortable reading these points of onboarding, cloud, ongoing maintenance. We know what it means and how it changes over the years, and what we can actually optimize and where. So scenario 2, 3, and 4. So onboarding cost is is pretty much the same in 3 and 4. 2 is like slightly less. And cloud costs in 2 and 3 are nothing because we are running on-premise. Of course, we talked about the cost of existing framework and the new systems when we talked about on-premise. So new system means I'm an organization. I have no infrastructure prepared for blockchain yet. I'm going to procure everything, set up a team around it and all, and then I'll do it. Existing means you got like some sort of infrastructure set up already. You got machines running, you got clusters set up internally, and then you would want to simply extend that to avail additional use cases implemented on some blockchain protocol. So you got a team which is already maintaining infrastructure. It is running already. It's already running on a tech stack, maybe Kubernetes, maybe Podman, maybe Docker based, and you're simply extending it. So that's existing infra. So just go back to this slide and see that we talked about that. Scenario 1 is cloud-based. 2 and 3 are on-premise, but the difference is existing technology and new systems. This is the difference. So new means that we are bringing in the whole idea of creating a cluster or creating an infra inside internally with new machines, new sort of orchestration and all, and then doing a protocol implementation on top of it, and then doing a use case on top of it. But existing means you may not have done blockchain yet, but you are already running an infra, you're running different sort of applications, maybe Web 2 applications on it. You're simply extending it, be it Docker-based, Kubernetes-based, or maybe simply VM-based, running on OpenStack or other sort of toolkits. So let's go back to this slide again. Now this is pretty much self-explanatory, and one common factor, if you would eye here, is the maintenance cost. Whatever you would do on-premise or on cloud, this is untouched. Your monitoring would reduce drastically if you're using existing infrastructure on-premise, because you have best practices enabled, you got all compliances settled. I'm considering an infrastructure which is already running blockchain stuff. But if an infrastructure is not running a blockchain stuff, we're calling it a new infrastructure. And that's where scenario 4 comes in play, and you have huge monitoring cost, even more than what you had on cloud, or maybe very equivalent to that. So if you have existing infrastructure practices ready for blockchain in your on-premise infrastructure, you're spending less on monitoring. But if you don't have that, even running on-premise won't help you much, and cloud and on-premise would run neck to neck in terms of how you would monitor, and you would spend about the same cost. And maintenance, it remains the same. Cloud turns to zero in case of on-premise. And onboarding cost, it runs pretty much the same for year 1 in all the cases, but in year 2, it reduces drastically. Now, the difference is not because of the infrastructure choice here. The difference is because, I'll go back to the slide. Look at the transaction size and the consensus protocol here. These are the parameters which are being, which are playing a major role. We'll have we have a dedicated slide where we'll talk about how these parameters impact and what they impact. But for now, this, this is to tell you that, where the difference is coming out of. Why, we'll talk about later in the slide. So on this slide, the focus is to be on where the difference is coming on, comparing the scenario 1. I'll maybe open up the Q&A piece here and take a break, let you guys think about it, and then we'll move forward. Right. So let's come on to the key inputs now. I just, I may be running it fast, but my focus is that, we spend most of the time doing Q&A because ultimately there are so many inputs. These inputs won't be enough. I may call them key, but they may be, key in some use cases and may not be key to some. And there may be some additional inputs which may be key to some which are not listed here. So this is, just a way to initiate, the approach, the art of taking it on when you participate, in an exercise internally and trying to, implement a use case for your organization. And this is one of the challenges you'll have to address. On a lighter note, usually, with our experience, we've seen that, the roadblocks are usually when we don't know how much we're going to spend in an organization. If you leave it boundaryless, it may well not happen anyways. So there's a question coming in from Jason. I think, before we touch on these key inputs, we can take the question itself. The question is, how do you measure the value an enterprise blockchain solution can create for a specific business. So this question, Jason, thank you for asking this. I think this is also relevant. Like I said, we'll be having this series. This is just one session. So I think this question would be properly answered in one of the follow-up sessions we'll be having, because this comes or directly points to the ROI when we are thinking about the use case implementations. How for example, supply chain itself. This question asks about that, how do I improve the supply chain track and trace capabilities using a blockchain implementation? What value I'm creating using blockchain into a specific use case? So this actually very use case to use case, and there has been long debates, legacy versus blockchain, transparency if needed or not, if the solution providers themselves are willing to adopt to it or not. The adoption challenges is another thing we'll talk about in follow-up sessions. But to answer it today, I would say that it is very use case specific, and the value creation would be very different in a trade finance use case comparing to a supply chain use case, or it may be very common as well. Like we're bringing transparency, or maybe cutting off the timelines wherever the documentation or the workflow management is to be considered. But then there could be very differentiating benefits as well. For example, if you are implementing an automated claim settlement use case for an insurance ecosystem versus an automobile part manufacturer is trying to settle warranties and bringing transparency against the counterfeiting systems. So there may be different use cases, there may be different benefits. And I think there are use case and studies which you can read on our website as well, and there are a lot of material available. But we would be covering this in a very specific follow-up session in this series itself, that how do you reach up to this point where you architect a solution, design it properly, and create value for a specific business use case. So I know I haven't done justice to this question, but I think it's slightly different from today's topic, but I promise you that we'll be covering in a follow-up session. Today, we'll be focusing upon the infrastructure elements, the cost of it, considering that we already have a use case and we have found a value in it, and we're doing blockchain implementation for it. And then what would be the cost of ownership and what points and factors to be considered. Right. So let's come back to our point of the key inputs. Now the key inputs we talked about in the opening slide as well, and I think we'll have to highlight them again here. One of them is transaction volume. Second is the transaction size. I'll talk about transaction volume and size. Of course, I know that the audience of mine today is very educated in terms of what blockchain is, how it works, what is transaction, what is the volume, what is the size, what are the factors. But I'll simply cover it in case there is somebody who's looking to have answers around it too. And then the node hosting method, I called it very important. We'll see and talk about why. And then consensus protocols. This may still surprise you that how it changes the game, but it is one of the key inputs, in my opinion, which impacts the cost of ownership in the end. And then monitoring and SLA management, we have seen why, because how cost varies from aspects of monitoring abilities and of course uptime demands of an enterprise use case and the cost implications of it. Let's talk about them one by one. And let's start with the transaction volume itself. So transactions are the basic elements of any I would say system which is running something. And in blockchain, we all know what transactions are for. They are the the most granular entity for execution. So whatever I would do on a network, be it through smart contracts or in any which possible way, I'll have to do a transaction to achieve it. And when I do a transaction, I'm executing something, I'm recording something, which means the volume of it matters. And most of us are legacy enterprise game veterans here, I believe, or maybe are well versed with it. So we know that every time we create any system, it has got some transactions inside it. Maybe it's a payment system, which is the most easiest to understand when it comes to transactions. You pay me something, it's a transaction. I pay something to somebody, it's a transaction. We buy something, it's a transaction. We we record something, we share something, we move something, it's a transaction in the digital economy. So it's pretty much it's pretty much the same. It's done differently on blockchain. It's recorded differently on blockchain. It's validated differently on blockchain, but it's a transaction. And now volume of it matters a lot, because when we say volume, volume means how much hard work are we doing a day, an hour, a second. And that may impact your outcomes big time, because whatever you do on digital machines, systems, even when you compute, it takes you some amount of CPU, it takes you some amount of storage, some amount of read and write on the network, your bandwidth, the internet bandwidth I'm calling upon. So transaction volumes matters a lot. It's like it's like the engine of your supercar, or maybe a very moderate one, which can rev up to certain RPMs. So that's the capability and the limitation of it. And the more you would demand, the more it would demand out of you. It's the same. So the more the transaction volume is, you would end up consuming more computing power. Means you would spend more on your infra in terms of cloud, or even on-premise. You would buy bigger machines, expensive machines, and then more storage. So you would plug in more drives into those machines. You would buy more, storage, block storages from your cloud providers. More network IO means you may have a global network, and you may have read and writes happening different across different data center regions of the different cloud players, which means you're paying for the read write cost as well, big time. And then the sum of it would come in as your infrastructure cost, and that may actually be a lot higher than you would imagine at times. So, and it scales pretty fast. This is why, if you go back to the graphs, just in our thoughts, not in our slides, then you would realize that this is why the onboarding cost in year one is like so high, but then it gradually decreases. But because in year one, you would do all the hard work to optimize your infrastructure in terms of compute, storage, and network IO. You would know what it takes to run a 50 stakeholder network, doing all sort of transactions, which would require the whole business to run. POCs and pilots are different, production solutions are different, and they may scale. And everybody wants to increase their business workload, because they would want to make it large. And this is how you would make it large. Any network which will have more transactions means that it means business, and you want it to make it go large. So this is how you balance your cost. And again, coming back to the question Jason asked, but I think this is not directly relevant to that. But the point says that this is one factor where you could think about the ROI of it. And then the second, important point is transaction size. It refers to the storage requirements. To store 1 unit of one transaction, I would say 1 unit means 1 transaction on the network. Now, network may not be just 1 machine. That's why I'm calling it so all of us must have heard of virtual machines, because Ethereum has been there for so long. So it's a virtual network. This is not 1 storage, 1 compute. You're talking about multiple machines coming together. When I'm saying machines, I'm saying nodes. When these are coming together, this philosophy remains the same. If it is the public blockchain or permission blockchain, you will have multiple nodes coming together, syncing data all the time, performing storage actions all the time, forming compute operations all the time. And then syncing means network operations all the time. So 1 transaction into n means your volume. N means your volume. We just talked about volume. But what each transaction would in itself be, if it is, how heavy it could be. So the heavier it is, the volume would impact it. Volume would be directly proportional, in the sense, you would consume even harder on cost. So transaction size matters. That's why, if you go back to the table, you would see that, why we consider large transaction size, 500 bytes or beyond, and then even smaller ones. And in the smaller ones, we could see that, the maintenance cost was slightly lower, and the monitoring cost was like pretty much the same, but the infra cost was like less, onboarding cost was less. So this is one of the factors which is also most important. Now, transaction size would not only increase or reflect upon your compute, storage, and network IO. It would also reflect upon the auditing and review pieces. So any use case which requires audit, which requires validation of the data, reconciliation of it in the past, then also the larger transaction size would create challenges if not challenges, then create cost on how do you analyze them all and go through them all. But this may not be the primary cost you would be bearing in year one. It may happen in year 2 and 3 and 4. So this is one cost which may come up in our table, but not as a primary cost. And one of the factors about transactions and size, volume, is of course all business specific. It does not have nothing to do with the blockchain protocol. So I'm choosing Hyperledger Fabric, R3 Coda, or Hyperledger Sawtooth, or maybe another enterprise blockchain protocol. Volume is all business driven. Your use case decides, your architecture use case decides what volumes you would be having, your need of the implementation. But size may still vary, because some of the protocols may have some different payloads and structures which will automatically be filled in. Of course, the core payload would depend upon your business use case implementation. It'll remain all the same for all the protocols, but yes, some sort of size would vary based upon what protocol are you consuming: R3 Coda, Hyperledger Fabric, or Hyperledger Sawtooth, or any other Besu, maybe other enterprise blockchain protocol. Then the node management method. This is I would say the most important slide of the day in our session, because node management can actually change the game for you. We saw how the monitoring and maintenance cost was like more than 60% of the total cost. I would say 70% of the total cost. If you go back to the table, you would see that those costs combined, you're spending more than 70% of the cost on just monitoring and maintaining your network. That's it. Onboarding done year one, you're not spending more money on that. I'll talk about how you can mitigate that as well, but you're spending more than 70% of your cost on maintenance, upkeep, and monitoring. Now, node management has a role to play in this. We talked about that you would have on-premise and cloud solutions, but blockchain services are multiple. So if you're doing Hyperledger Fabric, you may have order P, CS, this and that and all. In R3 Coda, this would look very different, but ultimately you would have some services which are core, some ancillary around it, and then you meet the overall requirement of your network as to how to run it. So be it on-premise or cloud-based, this won't change much until you have everything set up. But in our case, in today's scenario, we're considering that most of the enterprises, they don't have blockchain ready setup with them. Even if you have it, you may have 3 different models under cloud too. 2 different models, I would say. You may have a hosted cloud solution from a provider, or maybe the vendor which is writing the solution for you for a specific use case. Or you may go with one of your existing cloud partnerships. Maybe it is with AWS, Google Cloud, Microsoft Azure, or maybe Oracle or any other. And you would ask your vendor or implementation teams to come on and then do everything, all the setup and deployments there, and then maintain it there. But the key factor among all of them is, regardless of wherever you would run it, the cost saving comes out of how you're running it. Are you running it automatically? Are you running it manually? And what is the difference between automation and manual? So if we go back a couple of slides and take a look at the scenario 1, where we are burning here. So we are primarily burning on onboarding. How can we save here? So I'll just simply draw a scenario between automation and manual. Now, what manual onboarding means. So as an organization, I'll set up the solution. If I'm talking about a supply chain use case, I'm the manufacturer. I created a solution through a vendor, maybe any company who's building blockchain use cases. Now they have to deploy it somewhere. I'll provide them infrastructure, which comes under the cloud cost or the on-premise cost. Even if that is done using my existing cloud partner, then they'll start deploying the solution there. So this is where your onboarding cost starts. So going live and then inviting your stakeholders. Now, how do you invite? So I'm company A, you're company B. Now, as company B, you would also require some sort of expertise to onboard. You would require a lot of configuration, setting up and all nodes on your own, because in case of blockchain networks, even in enterprise scenarios, you just cannot have everything running under one umbrella with one party owning it all. So you would want all the stakeholders to run some piece of the meat with them, so that decentralization can actually happen or take place the right way. Now when that happens, your suppliers or vendors in the supply chain network, or maybe the distributors, they may not have the equal expertise or teams ready like yours. Of course, you're spending money on your onboarding, you have DevOps teams and all, but they may not have. Now how do you onboard them? Either you take that cost on yourself or you pass it on, but in both the cases it is the cost either on you or on them. So that's why onboarding cost is higher when you onboard manually. I'll talk about automation in a bit, how it is done and all, but manual means a higher onboarding cost. This is pretty evident, be it on premise, be it on cloud. Then the maintenance cost and monitoring cost. This is, I think, pretty much evident before cloud even existed. How we used to prepare machines on premise, all those wires, all those UPS power supplies, cables here and there and all, and 24/7 teams. This is what you have to have. But even if you put the infrastructure on cloud, you still need people which continuously monitor things. Then you automate some bits of it, but then the automation is not completely available on cloud, because cloud can only monitor your resources. It can monitor your machine level resources, infra related resources, but it cannot monitor yet the blockchain parametric level resources. What if my node is not syncing? What if it is stuck at a particular block height? What if it is, my network is having latency? Who's going to monitor that? And what if it is down? Who's going to debug and fix? So you would not only have a DevOps team, but you will have a DevOps team which has got additional blockchain expertise with it. That means cost. And that means pure cost. 24/7 team with blockchain expertise and all the know-hows you would require for your specific use case. And then the trouble becomes bigger when, like, in onboarding, you may have a team, but then what about the parties you onboarded? They may have it, they may not have it. So you're not just so maybe let's just simply sum it up in a way that this is what increases the ongoing maintenance cost, and this is why it remains consistent. And I'm talking about both maintenance and monitoring here, the way I structured the teams here for you, and I think you understand pretty well coming out of the enterprise scenarios. And like I said it previously, I'm saying it again, that most of you are already in the game. Or when I'm saying in the game, I mean that in the enterprise business, you have ran applications, you have seen how applications needs or requires the uptime, how that uptime is achieved, what sort of hard work goes in the back 24/7 to keep these very valued business networks up and running. And blockchain just simply makes it 50 times complex, 50 times costlier, I would say. So manually doing all this stuff would require more people with heavy expertise and 24/7, and it'll take more time. So it's not just about the cost, it's also about time, and time is money. If you're spending more time doing fixes, if you're doing taking more time, your business is also losing money. So that's an indirect cost you're consuming, which is not mentioned here. So if something happens to the network, my block count is not syncing on all nodes equally, I'm having latency which is affecting transactions, and specifically when the volume is increasing. So volume increasing, we talked about this, that's pure business for us. Being in the enterprise domain, if your supply chain transactions are increasing, that's real business. That means business to you. And if in this case the latency is coming up, some transactions are failing and all, they're getting delayed, they're not finalizing, then you're having trouble. So that's an indirect cost you're bearing, which is not mentioned here. But yes, monitoring, this is where you would love to spend more money on monitoring and maintenance. And this is why these are the two of the most important pillars among all of them. Now let's come back to our slide where we talked about transaction volumes and size, and what sort of we talked about a triangle of it, the relation between both of them, how the size would multiply when volumes would increase, and then how would it continue to generate more trouble for you, more cost for you in terms of how to maintain it and monitor it, because the more the more the volume is, more consistent resource allocation you would require at the back to keep running your business. Now we were at node management and we were talking about automation and manual, and we were comparing, how doing all those activities, which is primarily around onboarding, is affecting my cost, maintenance is affecting my cost, and monitoring is affecting my cost when done automatically or manually. Now, in automatically, when we say manually, of course, we draw significant details around it. That yes, manual is cost consuming. It is required, but it is cost consuming. Automation is better. It has got high availability. It has got better production outcomes. It gives you 99.9999959 policy, or maybe 99.995% uptime. Manual may actually takes a huge cost to achieve that, or may not achieve you that, because blockchain is far more complex than legacy systems. Now, even what sort of automation options do you really have? What kind of planning and preparations you can actually do or attempt? And so we'll talk about automation options later, but I'll simply draw what automation really means in case of all these onboarding, maintenance, and monitoring. So when I say automated onboarding, I mean that it has to be Facebook like simple. Invite a friend, invite a stakeholder in your network. Do not make them set up the similar sort of team, spend the similar set of time like you have done yourself. Do not even do it yourself. So automate everything since day one, and then pass it on to your stakeholders and help them participate in the network with ease without spending much cost, because automation is taking care of it. You spent one time on automation, or maybe through there are various tools you can subscribe to, and then consistently scaling without worrying much on the onboarding cost. So this would cut down your onboarding cost by 95%. And that's I think the Facebook would tell you why. Making friends in real world and making friends on Facebook, how cost effective that is. On a lighter note, sorry, I didn't mean that. No offense Facebook, no offense real world networking. And then automation on monitoring and maintenance, I would cover them as one. How so monitoring, when it comes to monitoring, we've seen how clouds have optimized, and there are so many tools which have optimized, like Grafana, Prometheus, and all, even Sumo Logic, and there are so many tools out there which has optimized our legacy infrastructure monitoring. But how about the blockchain infrastructure monitoring? There are tools for it too, and they have specific purposes and they do it. But if you will not talk about which tools and why and all that and all today, but if you use automation there, you again cut down your monitoring cost big time, because you would save on resources. You don't have to apply so many man resources 24/7. Considering the automation does it for you. It's very similar to how you've been feeling comfortable for years in cloud, using AWS monitoring tools, using Google monitoring tools, and you feel that legacy Web 2.0 world is pretty much safe for you, and you can sleep well because the automation is taking care of everything. So it's the same comfort I'm talking about here, but in the blockchain space. Now, the legacy tools may not accommodate it equally, but yes, if you have the tools and if you apply them right at the right time, you may cut down your monitoring cost by and maintenance cost, both of them, like by 80-90%, very simply. So where we were looking at like the bills of 250,000, 300,000 in terms of running a production grade enterprise network with everything considered into it, you would simply have like a cost of ownership which is not 300,000 but 30,000 a month. And that's real, that's practical if you follow the automation path. And automation is going to come anyways, today or tomorrow. We have seen that. It's been a history, and there is a timeline to our history, and we can always go back and look at it. Now, I'll take a pause. I'll let you settle everything in, and I'll see if there is anything in the Q&A. If not, we'll move on to this interesting aspect of consensus protocol. There may be many things we discussed today which most of you would already know, but I'm just you can then consider that I'm just trying to put them all in one construct, trying to connect them in a way that you would feel better about how do you do it right. What do you think all the time? But in the follow-up sessions, we would actually, make it very practical, very mathematical, and very driven. And towards the last session, you would be in a position where you can actually, like a Superman, exercise your capabilities, your expertise, your learnings into a fine implementation of a blockchain use case in one of your enterprises, be it your client or yourself. So we got a question from, Neeta. Thank you, Neeta, for asking this. She's asking that what can be automated in a blockchain scenario? So yeah, like Neeta, we just talked about, you can automate onboarding, you can automate monitoring, you can automate maintenance, and you can even automate, some sort of infrastructure pieces about cloud and on-premise implementations. You can automate almost everything. So I think I'll give you comparisons from Web 2.0 words. So when I say infrastructure automation, so we don't buy servers, put them in a rack. We don't plug cables. We don't do power supplies ourselves nowadays. We simply go to cloud and buy machines, right? So that's infrastructure automation from the Web 2.0 world. It may differ slightly in 3.0, but automating it means that. And then installing all sort of softwares you would require. So today you don't install softwares on your own. They're automated. They're stack stitched for you. So this is automation for infrastructure. And then automation for monitoring and maintenance. So in Web 2.0, we all have seen, how Amazon CloudWatch works, how, Sumo Logic works, how Prometheus Grafana works, how Zabbix works, how Splunk works, how so many other tools work. So they give you a lot of, help around monitoring and maintenance, and cuts your time, saves your time, and cuts your cost big time. And then onboarding, I think there is no better example than an ERP system where you would simply onboard suppliers and vendors and all, because it's a centralized system. It's pretty much easy. You own it and you do it without building a lot of hassle for them, and of course building a lot of cost on yourself as well. So these are the kind of automations I'm talking about in blockchain scenarios. But of course, this may be tougher, complicated, and even there are not much tools available out there yet. So this is what, to answer your question, I would say are the possibilities to automate in the blockchain scenario. I hope that answers your question. Then so yeah, as a follow-up, you're asking me differently that what is best to run manually instead of automation. So I would say that, run your head around what automation to pick. That's the only manual stuff you got to do. Put right people on top of, the command of automation, how to configure it, how to use the automation the best way. That's the only manual work I would suggest you should do. So today we only configure tools to monitor for us. We only configure tools to scale for us, maintain it for us. So that's the only manual piece you got to do. You don't have to worry about how the automation works. It's like, clockwork. You put this cell into the clock and you don't worry about how it ticks. That's a very thin line, but I think the sooner the tools would mature in the blockchain space, we would learn the difference very clearly, and I think it'll be very clearly mentioned everywhere else. And then another question before we can pick up the consensus protocol stuff. I think most of you must have read the slide already, so that's bad of me. But I think that fits the purpose, because I didn't want to talk about consensus protocol in a way because it's obvious. It's obvious, proof of work. I kept it because it's notorious. We don't talk about it. We don't talk about it very gracefully today, specifically when it's consuming a lot of power. So, so Neeraj, and one more question I'll answer later after covering up the consensus protocol. So thank you for your patience. So yes, proof of work, we were there. I put it up there because it is notorious in terms of how cost consuming it is because of the computation demand it has. So again, connecting back to the same logic where we talked about how computation would affect. Computation may be driven by transaction volume, maybe transaction size into volume, both. And then, of course, how the validation of blocks is happening on your network. And there may be other key factors as well, which reflects upon your computation needs. And consensus algorithm is one of them for sure. And I think proof of work is the best way to tell you why. And I think I also understand it the same way. I have also learned blockchain the same way. Proof of work was first thing in terms of consensus we learned. So we understand why it is notorious, why people talk about it not in a very good way today, and why it is compute hungry. So yes, consensus may be compute hungry and it may vary. So your choice of consensus actually can change how much you would be spending on your network as well. And I think the same on the same line, there is proof of stake, there is proof of authority, and then there are BFT algorithms. Your choice of protocol and then the choice of consensus would actually change the outcome. Right now, I think I'll before moving on through the next slide, I'll pick up some questions. We're doing good on time here, but I think we're not doing good on time. I think we'll have to jump onto the Q&A very quickly. I'll answer these questions. Niranjan Rajasekaran, thank you for asking this. He's asking that, is onboarding similar to deploying an app to a server in Web2 world? Now, I would say yes and no, both. Yes, because of course, in today's time, when we say we're running a software, it must run on some machine, and it must get installed in some way or other, be it Windows, you would be running an MSI installation, an exe or binary installation. It may be Linux, you would be running in a Debian package or an RPM or something like that. But yes, that's why I'm saying it's the same, but then the requirement of it may vary. So in the Web 2.0 world, somebody runs it on their machine and then they offer it to everybody else. You don't run it if you're consuming it. But in Web3 world, you participate. And when you participate, it means you also run something. And when you run something, it's not barely consuming or simply consuming it. It means you're running part of it yourself. So it's like, all those machines in a combination perform some computation, perform some storage, perform some networking level actions. And when that happens, it is participation. This is where it is different, and it cannot be owned, controlled, monitored, managed centrally. And this is the only difference. And that's where additional automation demands are required and are needed. I hope this answers your question. And then another question from one of the anonymous attendees. It's, how did you assess the security of an enterprise blockchain? What are the metrics you use to measure security? What tools or techniques do you use to prevent DDoS attacks and other popular cyber attacks? This question in itself is an attack. It's back-to-back questions in it itself. No offense. That was just on a lighter note. So picking up the first point, how did you assess the security of an enterprise blockchain? So the security comes into multiple aspects. One, of course, the legacy aspect. I'll have to secure all the machines I'm running my nodes upon. That's pretty much flat and very clear, straightforward to understand for everybody who's coming out of the Web 2 world. But then beyond that, there are other things which you'll have to consider. We have seen from the Bitcoin and Ethereum world, a very basic fundamental when we studied blockchain. That was about the attack types. There are different attack vectors here. I'll simply mention it to align your questions in the right direction. I'll not mention all the attack types because it would be a different session, independent session in itself. But we heard of majority 51% majority attacks. It means that we talked about consensus all the time when we talk about blockchain. It may be different when you're using BFT. It may be different, so n+2 by 1. If it's proof of work of pretty much 51% attack. So how much nodes you should have get compromised before this attack happens. So security in those aspects differ in enterprise blockchains based upon the consensus choice you have got. And how do you measure it? So measuring it means you'll have to know when your network is impacted, and that impact is directly when your use case is affected. And your use case means your consumers and the transparency of the data or the integrity of it which you're maintaining. So that's how you measure if something wrong has happened. I'm not covering the regular aspects. They must be taking care of, like malware, rootkits, other stuff on the machines. But then how do you keep the sanctity of the network alive? How do you keep it sane? How do you keep the consensus transparent and trustworthy? How do you keep the participations and the block validations measurable in terms of that everybody accepts it, right? So ultimately, it's all about the consensus and running it right. Then what tools or techniques do you use to prevent DDoS attacks? So DDoS is something which is the network level component. So distributed denial of service. There are different type of DOS attacks. There is DRDOS, which is distributed reflection, and then denial of service. Now, to attack on a blockchain network, this is slightly connected with the second question of yours. How do you measure security? So I focused upon consensus. So I'm considering a very fundamental case, for example, BFTs and all CFTs. So n plus 2 by 1, or 2/3 of the majority in case of any consensus, for example. Now this 2/3 of the majority, if it has to be compromised, I'll have to attack some machines, not just one machine. So DDoS becomes complicated here because these machines are not owned by one party. So usually in DDoS attacks, you attack an organization, institution, university, and then you get into machines, and then you from one machine hop into another machine and all. But in this case, there are multiple parties owning these machines, so it gets complicated. And very similar to DDoS, other cyber attacks becomes complicated. I'm not saying they become impossible. I'm not denying that completely. We still are vulnerable to attacks, and attacks happen, but it's like blockchain, tickles, or blockchain gets impacted in a different way, or it gets affected in a different way comparing the traditional networks and all. We may have so in the series itself has got like several sessions, and we will have a dedicated session on this in future as a follow, which talks about the security aspect, the do's and don'ts, the best practices, the guidelines and all. How do you secure it? How do you do what and all? So but I think for today's construct, I think this answers your question, and I'll simply move on to the next slide, which is about some general considerations. Again, I talked about this, but I'm just simply laying it out for you so that we keep this in mind, that this discussion we had today was not about establishing something like, oh, this is blue, this is black, this is white, or this is green and gray. This was about creating the approach around it. So whatever forecasting we did today, or you would do, it completely depends upon the specific use case you're trying to do, the protocol you're trying to implement, and what benchmarks are available for that protocol and that specific use case, or business surroundings of it. And then the more you would with time standardize it. That's why I consistently focused upon that year 1 and year 5 could be very different. And the reason being that in year 1, you simply set up the process. In year 2 and 3 and 4, you simply master it. And in year 5, you standardize it in a way. This may be a very long period. This could be actually, some short span you would have as well. So whatever we talked about, it may vary based upon protocol, based upon use case, based upon benchmarking, based upon data, and all sort of, implementation you would require, volume, transaction size. We already discussed the factors. Now, slightly about Zeeve. So I talked about automation a lot in the whole session. But so this is where we've been innovating ourselves. Zeeve automates a lot of blockchain related challenges, be it onboarding. So we have the platform which does automated onboarding for your participants. If you're doing Hyperledger Fabric, Hyperledger related protocols, maybe other protocols as well. So this automates that bit. It automates your monitoring, your maintenance, and not just cloud. It supports multiple clouds. So it caters to not just your needs, but your stakeholders' cloud needs as well. As one platform, you could serve all of them in a decentralized way. And then it caters to the cost of monitoring it 24/7, which of course is a cost, and then also help you with a lot of effectiveness in terms of incident management and recovering out of those incidents. So we have put in a lot of experience and expertise we had gained out of different implementations across the enterprise space into this automation we have built. And this is pretty much DIY. Sign up, start using it, and our team is available for free consultations if you would need. So you can connect us through the community. We have a community on Discord. So you can visit zeeve.io. You would know more about us and our community, or you can directly reach out to us as well. We of course will be uploading this session on YouTube. You can listen to it again, and you can maybe share it further. And then we would also be uploading these slides, so you can go through the numbers in your heads again. You would plan it well. And so that's about us and the details. We are a US based headquartered company. We have technology presence in India. We got presence in UAE as well. So I think time has already gone past the desired number. I would thank you all, and sorry I rushed you all into it, but there was like a lot to talk about. I really appreciate all joining in, and I would really want to thank you that that you heard it all. I would I would expect that you would all come. You would all bring these kind of things into practice. You would start making blockchain adoption easier. You would start contributing to the ecosystem better. And till the next session, thank you very much. There are two questions I think before we say goodbye, I would want to address, but I'll not hold you back longer. So Neeta is asking that how to access the other sessions in the series. So Neeta, I think they would happen the same way. We'll continue to upload all the sessions on YouTube to create a series for you, and you'll have the bunch of the stack available to you all the time. We'll upload the PDFs, so that you can look at the slides as a group. So it'll continue to happen, and I think you'll have the invitations available to you, like you had this one through GBA. Of course, I think we'll share the YouTube link as well. No problems there. This session is just a beginning. We can stay connected on Discord, and you can continue to asking questions there. We have a larger team there, not just me. There are more experts. There are more important people. There are more educated people there. And in fact, as an ecosystem, in fact, you can come in and others can come in, and we start helping each other there. So we'll share the Discord link. We'll share the YT link. We'll upload the PDF. We'll upload the recording. And till then, I think goodbye. See you all in the next session. Thank you very much for joining in. But I think before saying goodbye, Jason just asked a question. What is the good number for organization in an enterprise blockchain? Is having more organization make management difficult? What if? So Jason, to answer this, automation makes scaling easier, of course. But yes, having 1K organization is impractical in the sense that, any enterprise use case would be in limited boundaries. It may have 1K organizations, but you might not require all the organizations to join as an organization. When I said organization, or when we say organization, it may differ in practicality. So joining a blockchain network does not mean you would join as an organization. If it is Hyperledger Fabric, organization means something else. Joining means, you may end up consuming it, you may end up participating into it. So this depends. What are your needs and how do you tackle to them? But yeah, automation makes your life simpler for sure. Yep. Thank you everybody for joining in, and hope to see you in the next session as well. And thank you for bearing with me. I hope I delivered value you required. Bye-bye. Have a nice day, evening or night or afternoon. Bye-bye.